Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is a short episode where we're going to be talking about lattice enthalpy. And we're going to start by defining the lattice enthalpy of formation. The lattice enthalpy of formation is the standard enthalpy change when 1 mole of solid ionic compound is formed from its gaseous ions. So what process is going on here? So this is forming a solid ionic compound from gaseous ions. So for example, forming a mole of solid potassium chloride from gaseous potassium 1 plus ions and gaseous chloride 1 minus ions. That's not normally how we make ionic compounds, of course, and the lattice enthalpy can only be calculated. You won't be directly measuring this in the lab. Note again, this is a standard enthalpy change, so again, standard conditions of 298 Kelvin and 100 kilopascals of pressure apply to this. Something else to note about the lattice enthalpy of formation is that new bonds are being formed. No bonds are being broken, but new bonds are being formed. So that must be a process that gives out energy overall. So a lattice enthalpy of formation will always be negative. It will always be an exothermic process. There is also the opposite process, the theoretical process of breaking a solid ionic compound into its gaseous ions. And if we're applying that to 1 mole of our solid ionic compound in standard conditions, then we're carrying out the lattice enthalpy of dissociation. That's the exact opposite of the lattice enthalpy of formation. We're breaking bonds and not creating any, so this will always be endothermic. It will always give a positive measurement of energy. And because this is the exact opposite of the lattice enthalpy of formation, the value, the number, will be the same. So if our potassium chloride had a lattice enthalpy of formation when it was formed of minus 100 kilojoules per mole, for example, the exact opposite process, the lattice enthalpy of dissociation, would be plus 100 kilojoules per mole. The value matches, it's just positive rather than negative. We said we can't measure this process directly, measure the energy change, but what we can do, what we often do, is we use a Hess's cycle in order to be able to calculate the lattice enthalpy. And if you've been listening to this series of episodes, you already know that upcoming is an episode on exactly how to construct and use a Hess cycle. So that's all for this episode, for this micro topic. If you have any questions, please do come across to our Patreon community at patreon.com/chemistrymadesimple. There's also a link in the notes below. Ask your questions there. I'm going to be happy to answer them for you there as well. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistrymadesimple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.